Hello, ladies and gentlemen. Welcome to the screencast for the first day of the little unit on exploring uh, an ellipse. Ellipse is what we would most commonly look at as an oval. So it's a curve. It's a set of all points, and there's a whole lot of information up here about some of the distances R1 and R2. So it's this distance here, R2 and R1, from two fixed points, and those are called the foci, or the two focus points. Foci is the plural. And the sum of those is a positive number. It's a constant, so it's 2a. Okay? We're going to talk about all this as we go through this. The distance from one focus to the other is a distance called 2c. And again, we'll look at what that means. So this is the standard diagram of what we would look at for an ellipse. As you can see, this ellipse is long, and it's more wide, rather, wide left and right, than it is tall, top to bottom. So the major axis is the longer of the two. So we can see that this major axis of this ellipse is the horizontal axis, or the x-axis, because it's wider left to right than it is tall up to top to bottom, and that's the distance 2b is the minor axis. So let's take it. There's two axes of symmetry. So the axis of symmetry would be the distance left to right, right through the center. Oh, C, by the way, stands for center. Okay. And the other axis of symmetry is the vertical one going up and down through the center. The distance from the center to each focus is C. And they're equidistant. So the distance from center to focus 2 is the same as the distance from center to focus 1. And we'll see that mathematically. So the distance C is the square root of a squared minus b squared, and we'll talk about the a and the b terms of the equation. I know this is a lot of letters and a lot of words, but let's take a look at it. So the standard form for the equation of ellipse, and the center is at h comma k, okay? So that, okay, I didn't do that for that, but the center is at h comma k, the same as a circle. The major axis has a length of 2a units, and the minor axis is 2b units, okay? So if we look here at the equation, x minus h squared and y minus k squared, that's the same that we looked at with a circle, so that's similar, but they're fractions now, and it's always equal to 1. The equation of an ellipse is always equal to 1. So if you look at this, if the number under the x terms is bigger than the number under the y terms, the ellipse is wide. If the number under the y terms is bigger than the number under the x terms, then the ellipse would be more tall than wide. Okay? Let's take a look at it. There's a lot of steps to the lesson. So here's the equation of the ellipse: x minus 4 squared over 121 plus y plus 5 squared over 64 equals 1. Okay. So we're looking to identify the center. So if you follow down on your note sheet, the center of the ellipse is the same as we would find for the center of a circle. So it's x minus h and y minus k. But if you notice, it's y plus. So the coordinates of the center are 4, negative 5. 4, negative 5. So on the graph below, plot the center. So take a minute, pause the screencast, and you'll notice at the bottom of the page there's a graph. So plot the center of the circle and label it center. We'll put a big C next to it. It's at the location of 4, negative 5. So after you do that, the next thing we want to do is find A and B. Okay? Well, the number under the x terms is a squared, and the number under the y terms is b squared. So the square root of 121 is 11. The square root of 64 is 8. So the A term is 11, B term is 8. It's nothing more complex than the square root of the denominator. So when we do that, okay, change the color. Yeah. I get that same error message in school. All right. Okay, we're back. Same thing happens in small code in school. I don't know why. But anyway, all right, so let's continue. So what we're going to do is we're going to count boxes to find the coordinates of the vertices. So you start at the center. The center is at 4, -5. So if you count 11 boxes to the left, you get -7, -5. And if you count 11 boxes to the right, again from the center, you get 15, -5. So those are the two vertices on the left and the right of the center. So then, if you again start at the center, and you count up 8 boxes, you get one vertex as 4, comma 3, okay? And you go back to the center again, and you count down 8 boxes, and that gives you the location of 4, -13. So instead of trying to figure out what do I add to the x, what do I add to the y, once you plot the center, you just have to count the boxes. So those are the coordinates of the 4 vertices. So I talked about how to do that. You start at the center, and for the A, you count left 11 boxes, and the coordinates of that is -7, -5. Then you start at the center again. You count to the right 11 boxes, and that gives you 15, -5. You start at the center again, and you count up 8, which gives you 4, 3. You go back to the center, you count down 8, and that's 4, -13. I'll show the graph in a minute. So for now, count those boxes and plot those points that are there. Pause the screencast if you need to, and then come back to this. Okay. So now we want to find the coordinates of the two focus points. Now on the front page, it said that C, the distance from the center to one focus, is the square root of a squared minus b squared. Well, a squared is 121, b squared is 64. So it's the square root of 121 minus 64, or the square root of 57. And in this case, it's okay to round because we're going to graph this, and since we're not using a geometry sketch pad or something like that, it's okay to estimate the purposes of just to see where the two focus points lie on the graph. When we complete the graph of the ellipse, that's fine. So the two focus points have to lie on the major axis. So since this ellipse is going to be wide instead of tall, you start again at the center, and you count to the right about 7.5 boxes. Then you go back to the center, and you count to the left about 7.5 boxes. And what I did is I just showed this mathematically here. So we're going to take the 7.55, add it to the x value of 4, and you get 11.5. And then you subtract it from the x value, again, going back to the center, and you get -3.55. So the coordinates of the two focus points is 11.55. Why is there 44? That's the typo. I'll fix the typo. So it's 11.55 here, comma -5, and -3.55, comma -5. Let me see if I can fix this. Oh, that didn't really fix it. That doesn't look very good. So Anyway, it's 11.55 and negative 3.55 comma 5. So what we have now is enough points to be able to graph this ellipse. So if we take a look at this, here's the graph. I actually use the drawing tool to draw the ellipse because, as we know, my drawing skills are just so great. So here I plotted the center, which is the first thing I told you to do up at the top. Then I told you to count from the center to the right 11 boxes, and that's this point here. Go back to the center. I said count to the left 11 boxes. Then I said, again, back to the center, count 8 boxes up, count 8 boxes down. Then when we figured out the distance from center to focus, I said start here and count about 7.5 boxes to the right. 1, 2, 3, 4, 5, 6, 7.5. Then count 7 to the left. 1, 2, 3, 4, 5, 6, 7.5. So that's where the 2 focus points are. You will have the coordinates of them. One of them has a typo, 11.55. So once you've drawn the 2 focus points and the 4 vertices, you can then draw a smooth curve and connect the 4 vertices. So if we were to look at what the axis of the 2 axes of symmetry here, one is going to go left and right through the center and through the 2 vertices and through the 2 focus points. The other one will be the vertical symmetry. Again, it goes through the center and goes through the 2 vertices, the one above and one below. So the red dotted lines are the 2 axes of symmetry in the ellipse. So if you fold the ellipse on either red line, it's symmetrical. It'll match up. So take a look back at the screencast. Take a look at the notes I have here. We'll go over these in class. I have some more example problems that we'll go over in class. It's not nearly as complex as it looks. I know it looks like it's a mess, and it really is not. So just hang in there and be patient. Again, replay the screencast because it's important that you're able to look at this and be able to graph an ellipse. So thank you for tuning in to the first of the Ellipse screencast lessons, and I'll see everybody in class. Thank you.